This video is going to talk about the difference between speed and velocity. We often think about these two terms, or we think about speed as how quickly something is going. We talk about objects moving at a particular speed. We don't as often discuss velocity in the real world. Everything is usually in terms of speed, which is the rate at which an object is moving or covering a distance. Speed is scalar and does not depend upon direction, so it cannot be negative. You cannot have a negative speed. Whereas velocity is the rate at which an object changes position. So again, the direction that the object is moving is what matters. Velocity can be positive or negative. And again, that positive or negative, that sign is giving you an indication as to whether or not the object is moving in a positive direction or a negative direction. So in this example here over in the picture, you have two cars both moving at the same speed, 300 kilometers per hour, but since one is moving to the right, it has a velocity of positive 300 kilometers per hour, and so the other is moving to the left, it has a velocity of negative 300 kilometers per hour. But again, the speed is the same, and the direction is simply there to signify, or sorry, the sign is simply there to signify which direction the object is moving. To calculate speed and velocity, the equations are similar, but because speed is dependent upon distance versus displacement, the equation for speed is speed equals distance over time. So S is speed, D is distance, and T is time. For velocity, because direction matters, we can't use the distance the object covered. We have to use the displacement of the object. So velocity is displacement over time. And remember, if you're not given a specific displacement, like one singular value, you can figure out what displacement is by having the final position minus your initial position. So let's talk about the units of speed and velocity. Both of them are going to be a unit of distance divided by a unit of time. So for example, mile per hour, kilometer per hour, meter per second. You're always going to have a unit of length divided by a unit of time. They don't always have to be in meters per second. Meters per second is the general standard. But if you're given a problem where somebody is moving at kilometers over specific hours, you can leave it as kilometers per hour. You don't have to change it into meters per second. But meters per second is the general accepted rule for velocity. So let's look at a couple examples. In the first example, a swimmer takes 72 seconds to swim exactly 110 meters. What is the speed of the swimmer and what is their velocity? The first thing you always want to do is list out what you know from the problem itself. So I list my three variables for my speed, distance, time equation. So I have speed is what I'm trying to figure out. The distance I get from my problem, which is 110 meters, and the time is 72 seconds. Then I can substitute it into my equation. Speed is distance over time. So I put my 110 meters divided by the 72 seconds, and I get a speed of 1.53 meters per second. So that's the speed of my swimmer. My velocity, I do the same thing. I'm going to list all three variables. In this case, because the swimmer only went in one direction, the displacement is identical to the distance. So in the end, my speed and my velocity are both 1.53 meters per second. In this example, what is the speed and velocity of a runner that travels from the 6-yard line to the 2-yard line on the football field in 3 seconds? Again, there are my three units for the speed equation: speed, distance, and time. The total distance covered between 6 to 2 yards is 4 yards. And again, because it's speed and it's scalar, I don't care about the direction, so it's going to stay a positive number. and then my time is 3 seconds. So I end up with speed is 4 yards divided by 3 seconds, which gives me 1.33 yards per second. Okay, now let's look at the velocity, which is going to be different from speed this time because of the directionality of this movement. Velocity is what I'm trying to solve for. The 6-yard line is my starting position, so my xi. The 2-yard line is my final position, so my xf. And my time is 3 seconds. So when I substitute that into my equation, I'm going to end up with velocity equals xf, which is 2 yards, minus xi, which is 6 yards, divided by 3. So I end up with a negative 1.33 yards per second as my final velocity. So the magnitude of them is the same because, again, my person only traveled in one direction. However, there is a sign difference because velocity pays attention to the direction. So this tells me that the runner ran backwards at a rate of 1.33 yards per second. Last example, cross-country skier travels 180 meters to the right, 140 meters to the left, 100 meters to the right over the course of 3 minutes. What is their speed and their velocity? So I'm trying to find their speed. For their distance, I'm going to add all three of those distances together to get a total of 420 meters, and my time is 3 minutes. So when I do the math, when I substitute the 420 and the 3 into my equation, I end up with speed equals 140 meters per minute. Now there's a couple of distance changes, or direction changes here. So my velocity is going to be very different from my speed. So velocity is what I'm trying to solve for. To find my displacement, these are distances, not positions, as we spoke about in the distance versus displacement video. You're going to want to pay attention to the direction and add or subtract those values. So 180 to the right is positive, minus 140 because it's to the left, plus 100 to the right gives me a total displacement of 140 meters, and then my time is 3 minutes. So when I substitute those into my velocity equation, my velocity is 140 divided by 3. So my velocity is 46.7 meters per minute. So there is a pretty big difference between my speed and my velocity, and that is because there were direction changes within the problem.